Hey guys, welcome to question 3 for the 2019 Level 2 Calculus exam. So Matteo is operating his remote controlled car, which is moving back and forth along a straight track. The car's distance, s meters from a point P on the track t seconds after leaving P, is given by the distance is equal to 6t minus t squared. Find the initial speed of the car. So right now we have our distance formula, and we're going to differentiate in order to find our velocity. Formula. So our v of t would be 6 minus 2t. Alright, so in this case, the initial speed would be the c value, which is also known as basically the c value is the one that has no t behind it. So basically just the 6 would be the c value. So therefore our initial speed is actually 6 meters per second. So we can say messy handwriting. Therefore, our initial, why is it hour? Sorry. Therefore, the initial speed is 6 meters per second. And this will definitely get you an achieve grade here. So achieve this question. How long after leaving P does the car change direction? So basically, the car is going to start moving in, for example, one direction, and we'll call that a positive velocity. So for example, if it's moving in the right direction, that's going to be, for example, 6 meters per second in the right direction. However, if it's going to the left, we will consider this as a negative velocity because we consider the right as positive, we consider the opposite direction as a negative. So in this case, how long after leaving P does the car change direction? So when it refers to a car changing direction, that means that the velocity has changed so that the velocity is less than 0. So it begins going in the opposite direction. So in this case, our v would be less than 0. Our v of t is equal to 6 minus 2t. So therefore, 6 minus 2t is less than 0. Therefore, 6 is less than 2t. Therefore, t is greater than 3 seconds. So basically, you can state after 3 seconds, basically. Alright, so I'm not too sure on this question. It's either a merit or achieve question, but I'm leaning towards an achieve for this question for finding the speed. For finding the time, sorry. Yeah, I'm leaning towards, I think this might just be an achieve question as well. How fast is the car moving when it reaches P for a second time? Alright, so we'll have to read the question again. In this case, the car's distance, s meters from point P on the track. So the car has traveled a certain amount of distance from point P. So point P is where the distance is measured from. However, the question is asking when it reaches P for a second time. So basically, the distance from P at P would be 0. So we're gonna find our the time for when the distance is 0. So our s of t we know was I think it was 6t minus t squared. So we want this for when the distance is 0. So negative t squared plus 6t equals 0. So if we do a calculator work here, we should get negative 1 and 6 and 0. So we have t equals to 6 or t equals to 0. Alright, so in this case, we have to use our thinking outside the box here, okay? So our t equals to 0, that's when the journey has started. And that means the car starts at P and begins moving away from P. And then after 6 seconds, so basically after 3 seconds here, we know after 3 seconds, it changed direction. So after it changed direction, it starts moving back towards P. And after 6 seconds, it reaches P for a second time. So because we can eliminate t equals to 0 because that's the first time when it reaches P, because it starts at P. When t equals to 0, it started at P. It moves in one direction, and then after about 3 seconds, it changes direction, and then after 6 seconds, it would have reached back at P. Alright, so that's our time. We're not quite done. We have to go to our v of t now, because it says how fast is the car moving. So v of t equals to 6 minus 2t. So we're going to substitute v of 6 equals to 6 minus 2 times 6 equals to negative 6 meters per second. Alright, so remember in question 1, I was talking about for example, the opposite direction would mean negative velocity. So this negative 6 just means that this is positive 6, but in the opposite direction that the car was initially moving in. So for example, the car was initially moving this way, it changed direction, so it began moving this way. So let's say that for example, the velocity that was moving in initially was positive, so therefore when it changed direction, the velocity became negative. So this negative 6 just represents 6 meters in the opposite direction that was initially moving in. So we're going to write this as a statement to finish off. So we're going to say, this means that the car is moving 6 meters per second in the opposite direction it was initially moving in. And that would be your answer. And I'm thinking that for this question, it should be a merit level question. So if you have the correct velocity and the correct justification, you should get a merit grade for this. And to get an achieved, I'm thinking that if you find the t equals to 6 here, that will be an achieved. T equals to 6 or t equals to 0 will be an achieved grade. Alright, moving along. A parcel in the shape of a rectangular cuboid with a square cross-section is to be sent to the post. The sum of the length of the cuboid and the perimeter of the square cross-section is to be 100 centimeters. It's to be 100 centimeters. Find the maximum volume of this parcel. So explain how you got a maximum, not minimum. Okay, so basically, this is a cuboid, and this is a square cross-section. So this means that this will be a square. So this would be x, and that would be x, and let's just say the length is, for example, L. So basically for this question, the length of the cuboid, that's L, plus the perimeter of the square cross-section is to be 100, so plus the square cross-section, which is 4x, is to be 100. So for example, if we rearrange this equation for L, so we can say L equals to 100 minus 4x. Alright, for this question, we're gonna find an equation for the volume of the parcel. So the volume is length times base times height. Base is x, length is L, and height is x. So therefore, our volume equals to L times x squared. And because we have our equation for L in terms of x, we can substitute this equation back into our volume formula. So volume equals to 100 minus 4x times of x squared. So this will become volume equals to 100x squared minus 4x power 3. Okay, so for this question, we have our volume formula now, and we want to find the maximum possible volume of the parcel. So that's basically a turning point, okay? So in the turning point, the gradient is 0. So we're going to differentiate to find our gradient function. So dv over dx equals to 200x minus 12x squared. This would equal to 0 because a maximum means it's a turning point, and that's gradient equals to 0. So 200x minus 12x squared equals to 0. And you don't even just do everything in your graphics calculator because it saves a lot of time. So you should get that your x is equal to 50 over 3, or x equals to 0. Alright, so we have to explain that our answer is a maximum, not a minimum. So we're going to use our second derivative test. So our d squared v over dx squared equals to, if we differentiate a second time, that's 200 minus 24x. Alright, so we do d squared v over dx squared of x equals to 50. So 200 minus 24 times 50 over 3. That should give you an answer of 200 minus 24 times 50 over 3. That should give you a negative 200. Yeah, that should give you negative 200. This is a negative, so therefore this is a maximum turning point. However, if we substituted x equals to 0, we would get 200 minus 24 times of 0, which equals to 200. So this is positive, so this x equals to 0 is a minimum. Alright, so right now we can substitute 50 over 3 back into our volume formula. So, or we can just substitute back into our, like, looking at our picture. So our x equals to 50 over 3, so that's 50 over 3. This is 50 over 3. And L would be 100 minus 4x. So 100 minus, apologies for that. So 100 minus 4 times of 50 over 3. That is 100 over 3. 100 over 3. So we can just times all of this together. So v equals to 50 over 3 squared times 100 over 3 to the power 2. Sorry, so 50 over 3 squared times 33.3. We should get our v equals to 9,259.26. 226, yeah. And our unit would be it's in centimeters, so centimeters cubed would be our final answer here. So getting this final answer should get you an excellence grade. I'm thinking an excellence grade to find the volume. In terms of getting a merit grade, I'm thinking if you find your volume without the justification, so volume without second derivative test would be a merit, or if you can find this x equals to 50 over 3 or x equals to 0, that could also be a merit grade. Or if you just write your equation, if you set up your equation for your volume, that might also be an achieved grade here. Sorry, this is U. So I'm thinking an achieved grade for setting up the equation. Yeah, that looks right to me. So there are 2 points A and B on the graph of the function f of x equals to x cubed minus 3x squared minus 4x, where the tangent to a graph passes through the origin. So find the coordinates of points A and B and the equation of each tangent. Alright, so this was a pretty challenging question. And you know that the equation of a tangent is y equals to mx plus c. However, the tangent passes through the origin, so it passes through 0, 0. Alright, so just using an intuitive here, so if a tangent passes through 0, 0, then the c value would be 0, because if I substitute the point 0, 0, so 0 equals to m times of 0 plus c, so 0 equals to 0 plus c, so therefore our c would be 0. So therefore in this tangent graph, because it passes through the origin, it has no c value. So our actual equation for our tangent is actually y equals to mx. Alright, so you know that the tangent and the function will touch. They will touch each other because tangent to a graph, they're equal at that x point. So we can put our f of x is equal to our tangent. Or in other words, our x cubed minus 3x squared minus 4x equals to mx. If we move the x to the other side, we can divide everything by x. So that's x squared minus 3x minus 4 equals to m. So basically, our gradient can be rewritten as x squared minus 3x minus 4. However, the way we can figure out this m is by using our gradient function, which is our f dash of x. Our f dash of x would be 3x squared minus 6x minus 4. And our f dash of x is also another equation for our not tangent. It's also an equation for our gradient as well. So basically, this is also our gradient. So now we have a two things are equal. So this also technically this also equals to the gradient, because the f dash of x represents the gradient of a tangent at that point. So therefore, if we put x squared minus 3x minus 4 equal to 3x squared minus 6x minus 4, we can solve this equation. So we have 0 equals to 2x squared minus 3x equals to 0. If we use our graphics calculator, we will have 2 and negative 3, and that should give us our answer as x equals to 3 over 2, or x equals to 0. So this is the x points of our tangents, okay? And now we want to find the equation of the tangent. We do this by substituting these x points back into our gradient function in order to find our in order to find our gradient, aka which is also our equation of the tangent. So for example, we use x equals to 0. We can use on any of these two equations. We can either put it into this m equation or this m equation. It doesn't really matter. So for example, we can put it into this equation here. We can say 0 squared. Oh, not red pen. Sorry. So we can say 0 squared minus 3 times 0 minus 4 equals to m. So therefore, our m gradient here would be -4. And because y equals to mx, so therefore one of our tangents will be y equals to -4x. And we need to find the coordinates as well. Find the coordinates of points A and B. So our coordinates can be found by substituting the x point back into our tangent. So basically, y equals to -4 times 0, and this also equals to 0. So therefore, our point A, for example, our point A can be 0, 0. Yeah, point A is 0, 0 when the tangent is -4x. Alright, so for our other x value, 3 over 2, we're going to substitute and find our gradients. For example, 3 over 2 squared minus 3 times of 3 over 2 minus 4. So I'm just using this equation again, so I'm confused. So it's just 3 over 2 squared minus 3 times 1.5 minus 4. You should get your answer as -6.25. So therefore, that's our gradient, and therefore that is also our equation of our tangent. So y equals to -6.25x. And in order to find this y point, we can just substitute our x point into our tangent. So y equals to -6.25 times 3 over 2. And that should give us an answer of -3.975. So our point B would be 3 over 2 at -9.375, and the equation of the tangent would be -6.25x. And that would be all to this question. And if you get both point B and point A, that's definitely an excellent grade for this question. So both of this correct, as well as the gradient correct, not gradient correct, as well as the equation of the tangent correct, you'll get an excellent grade. In terms of a merit grade, I'm thinking if you just have one of these points, so for example, if you have -4x and the coordinates, you'll get merit. And to get an achieved, I'm not too sure where the achieved lies on this question, so I'm not too sure, so I'm not going to say what I think. If I had to say, an achieved it could be differentiating a function, but not too sure on this. Yeah, I'm not too sure, but that would be the answer to this question. Alright, so thank you for watching this video on the 2019 Level 2 Calculus exam walkthrough. I hope you enjoyed, and I hope to see you all in the next one. Thank you. Bye.